Welcome back to the R Learning module. Starting from this video, we will be learning about data visualization methods for R language. This video will start with brief introduction of data visualization, R packages, and followed by Scatterplot creation and save file tutorial. Please get ready and let's move on. Data visualization is the graphical representation of information and data. By using visual elements like charts, graphs, and maps, data visualization tools provide an accessible way to see and understand trends, outliers, and patterns in data. In the world of big data, it is easy to obtain a large amount of data. But if you only collect data and don't know how to analyze them, then the data cannot create any value. The most important thing data visualization does is to present a story. A visual art is always the best way to grab a person's interest and keep eye on messages. There are many tools to conduct data visualization. You may wonder why we need R if we have Excel to do the work. It is because of the difference in capacity between the two softwares. As you learned in the first module, when we are conducting big data analysis, it is still better to work with R. This is the reason why we included data visualization in this starter pack series. In R, the code of data visualization is written in an additive way. Elements of charts and graphs are added one by one in the command. For instance, this is a command for you to create a scatter plot with data points, linear trend line, title, labels, and source. Each element is added to the command with the plus operator. This is just a brief sample for you. We will take a deeper look at how it works in the later part of the video. Before starting with codes, you need to understand a more basic concept, which is the R packages. A package in R is the fundamental unit of shareable code. It is bundled with code, data, documentation, or tests, and it is easy to share with others. R possesses more than 14,000 packages. The large number of packages allow R users to solve problems with packages that others provided, saving time and effort in building new solutions. To simplify, when you are doing data analysis in R, you can use packages to speed up the time for code generation. Let's take a look at how to install and load packages. There are two methods to do so. The first method is to use codes. Suppose that we want to download the package called survey. We need to type in the install.package command and put the package name inside the brackets with quotes. After running the command, the survey package is now installed. The next step is to load the packages. The command for loading is library. By putting the package name inside the brackets of library command, the package is now loaded and ready for use. Be reminded that when using loading packages, the package name should not be in quotes. Another way to do so is to use the interface of RStudio. You can go to the Packages pane and select Install. Type the package name in the Packages column and click Install. You can see that the console shows the result of succeed in installing the package. To load the package, you just need to click on the package in the Package pane, and the package will be loaded. Now, let's move on to the data visualization demonstration. This video will focus on the scatter plot. Line chart, pie chart, and bar chart will be covered in other modules. The data set for demonstration is a daily sales data in July with dates named as trade. To analyze the trend of revenue, we can use a scatter plot. Scatterplot is used to see the relationship between two variables. To create a scatterplot, you need to install and load the ggplot2 package. This is how you can do it. After installing and loading the package, we need to read the file into R. Since the file is in CSV format, we can use the read.csv command to import file. To check whether the file is imported, you can check the dataset in the workspace window. As mentioned earlier, data visualization in R is done in an additive way. We need to conduct the basic element first and then add other elements on it layer by layer. The first step is to draw the graph with data points and specification of x and y axis. To do so, we need the ggplot command. Inside the brackets, put the file name first and then use the ACE function. Inside the brackets of ACE, you can specify the x-axis and y-axis. In this demonstration, we are examining the relationship of cells and transaction time. So x-axis is trade and y-axis is sales. As for data points, if we want to show each data point in the chart, we need to add the join point command in the code. This is added by a plus operator. Run the whole command and we can get a simple scatter plot with data points. You might want a more colorful graph. The color and size of the data points can be changed. Suppose I want to change the points into blue and make them bigger in size. I can set size equals to 2 and colors equals to blue inside the join point function. This is what you will get after running the command. This graph may be unclear as viewer might not know what the value each point represents. You can add a label to each point. In this case, data points represent the sales revenue for each transaction. So I will set label to the data source of data and sales. Type in the geom text function and set label equals to your data table and specify the column. This is what you will get after running the command. As you may see in the graph, the data label is overlapped with data points. Hence, we need some customizations. There are vjust and hjust to move the elements around vertically or horizontally. To move up the data labels, let's try to enter the code vjust equal to -0.5 and see how it changes. The texts are now moved above the point. Here, you may notice that the code is not moving the text relatively to the y-axis. In fact, it is relative to the whole graph. But to make it simple, you just need to remember that the default position is 0.5 in hjust and vjust, and that setting in a positive number is actually moving the text downward or leftward, vice versa. To examine the trend of the dataset, you may also add a trend line to the graph. As the data point in this graph has a linear trend, let's draw a linear regression line in the graph. To do so, the geom_smooth function is applied. Inside the brackets, set method to lm, which represents linear method. Moreover, you can set the line to whatever color you like. In this example, the line is set to be red by setting color equals to red. With this line created, it can show the trend in a clear way. If you want to use this scatterplot in a written report or essay, you might need to add a title, data source, and change the name of x and y axis. The lab function can do all these jobs. In this example, you can add a lab function to the previous command. Then set the title to be July sales, x-axis to be trade date, and y-axis to be sales. We can also set a caption for citation or any other descriptions like this, which will be shown in the bottom right corner of the graph. Now run the code and you can see the results. Suppose that this is the scatterplot that you want to use in your report. You can save it to your computer in several different ways. Here, we will introduce 3 methods. First, go to the Export button in the bottom right window. Click on it and you can change some settings before exporting the graph. Second, zoom the graph to manually adjust the size you like. Then, right-click your mouse and select Save Image As. The third way is to save with code. The most important thing is that this method allows you to save the graph with higher DPI. You can understand this as resolution, and that the default DPI is 100 R. Use the ggsave function and put the file name, file format, width, height, and DPI inside the bracket. Then you can export the file to your computer. To wrap up this video, you learned about the concept of data visualization and R packages, as well as methods to create a scatterplot and save it to your device. The concept of citizen data scientist is already on the rise. Not only engineering students need the skill of data analysis, but everyone should be able to read data and tell a story about it. Keep an eye on our next few series. We will cover more visualization topics. Next module will introduce line chart to you, which is also a useful visual graph type. Please move on to the next module.